Okay, now that we've had some practice with planes and three-dimensional graphing, um, we can now move on to systems of planes. So you've seen systems of linear equations before in two variables, x and y. And now we're going to start talking about solving systems with three variables, including z. So let's start this off by looking at a system. And if I grab a color here. All right, so if we have a system, our systems of three variables are always going to look like so. We could have 2x minus y plus z equals 4, and then x plus 3y minus z equals 11, and then 4x plus y minus z equals 14. Okay, so here is our system with three variables, and these are all representative of planes in three dimensions. So we could actually graph these, and our solution would be where all three planes intersect. Now, if all three planes intersect at one common point, then we're going to have one solution. If they intersect along a line, we'll have infinitely many solutions. And if they don't intersect at all, or if two of them intersect and maybe the third one doesn't, or all three planes maybe are parallel to each other, then there is no solution. So let's look at this system here. The first thing that we want to do is we want to eliminate a variable. So you've seen systems of equations, linear equations, using elimination, same idea. We're going to eliminate a variable by combining two equations or adding them. And I think the easiest one here is, it's fairly obvious, is going to be the z. So let's look at the first equation and the second equation and see if we can eliminate the z variable. So if we take 2x minus y plus z equals 4 and add it to x plus 3y minus z equals 11, our sum will be 3x plus 2y and then plus 0 equals 15. So we've eliminated the z variable, and this is helpful because now we can get an equation that has x in terms of y or y in terms of x that we can substitute back in. So let's now write our new equations. So we can now label as our fourth equation. If you want to think about it this way, as the fourth equation, the first equation, second equation, third equation. So we can now write the new equation as a system with a second equation, which we can create by combining our second and third equations. So if we write this as x plus 3y minus z equals 11, and then we can combine this with our third equation, 4x plus y minus z equals 14. All right, now if I do combine these here, and I use addition, I'm not going to eliminate the z variable. So what I should do is subtract the second equation or multiply the second equation by -1. Either one would be the same thing. So if I multiply this whole thing by -1 and then combine them, we would get x combined with -4x, which is -3x. And then we'd have a positive 2y. This would be plus 0. And then this would be -3. Okay, so now we can take, so then we could label this, if we would like, our fifth equation. Okay, so now if we'd like, we can actually write a system of these fourth and fifth equations. So we can have 3x plus 2y equals 15, and negative 3x plus 2y equals negative 3. So now we have a system of our fourth and fifth equations. Both are just only in two variables, which are much easier to work with. And we can combine these to get an expression for y, because I can already see that if I combine these two equations, the 3x and the negative 3x will cancel. So these will cancel out, and I'll be left with 4y equals 12. Okay. So solving for y here, we divide by 4 on both sides, and we're left with y equals 3. So there we go. We have an expression for y, and the next step that we have to do is go back and substitute this value for y into another equation that we have to try to figure out one of our other variables. Now, the best way to do this is if we could plug it into another equation that only has one other variable in it. Well, we solved for that right here. So either of these would really work. So if we were going to pick, let's pick the positive ones because that's a little bit easier. And I can plug it in as 3x plus 2 times, and our new y value is 3, equals 15. So then if I subtract 6 from both sides, I'm left with 3x is equal to 9. So x is equal to 3. So x and y are now equal to 3. And now we have an expression for x, we have an expression for y. Both have values now. And the last thing that we're left with is to solve for z. So we can actually go back to any of the equations that we have that have a z in it, plug in x, plug in y, and then solve for z. So if we were going to do that, we could take, I'm just going to change colors. We could take the 2x minus y plus z expression equals 4, our equation. And then we can plug in x and y as 3, so 2 times 3 minus 3 plus z equals 4. 2 times 3 is 6, minus 3 is 3, and then we bring 3 to the other side, and we're left with z is equal to 1. So the final solution that we are going to write is actually, we're going to write it as an ordered triple. So we've seen the ordered triples before when we were graphing planes, and we're just going to write it just like we would write an ordered pair as x comma y and then comma z. So 3 comma 3 comma 1.